54, the question started off telling you that this was going north 20 degrees east. So if you start off going north and then you adjust your course 20 degrees east, remember that your theta value is actually going to be the 70 degrees. If your magnitude is 500, to find the east component, that's your horizontal component, so you're going to use cosine. And then to find your north component, that's your vertical component, so you're going to use sine, but you do have to use the 70 degrees. Okay, additional questions for me in 74? Or 54? Okay, let's look at 57 then. So for 57, you had a wind that was going north, and it was at a speed of 30 miles an hour, and then you want to head in the direction west, okay? So if you want to head in the direction west, what I do is I make west my result vector, okay? This is my true velocity. That's why I have it dashed. And then I don't know what direction I'm going to be heading, so then I just drew this to represent the airplane, and this is going to be my theta value. Now, I'm going to go over how you know where to put your arrow, because that's really going to help you when you're writing your bearings and your final answer, okay? So one way you can think of it is if the wind is going to the north and you want to go to the east, okay, you're going to have to fly, to the west. If you want to go to the west, you're going to have to fly southwest in order for that northern wind to push you up to go directly west. Okay, does that make sense? So you're going to be flying somewhere in this direction, southwest, because that northern wind is going to push you so you're going directly west. Okay, so when I drew my picture, I started with my wind, and I knew where I wanted to go, and then I just drew my vector here. Now really, this is not going to be an accurate picture, because when you see what theta is, it is going to be very, very small. Okay, so it's going to look more like this. Okay, but this is a good way to visualize what is actually happening. So from there, what we're going to do is we're going to draw out our vectors for the wind and for the airplane. So you're going to take the magnitude, and if I'm going straight north, I can use 90 degrees, or you can also rationalize that this will be 0 left or right, 30 units up, so it would be 0, 30. And then for the airplane, it's going to be the magnitude cosine of the theta that we don't know, and then the sine of the theta that we don't know. Now, our true velocity is going to be the addition of those two vectors together. And we know that if we're trying to head west. See, we always do east, and now I keep saying west. Okay, if we're trying to head west or even east, which component has to be 0? It has to be the vertical component. Have you guys kind of seen a little pattern with which one you're going to set equal to 0? Okay, yeah, it is always the opposite, right? If you want to go east or west, it's always going to be the north to south component that's 0. What about like with the numbers? Exactly. It's always the one where something is added to it. And that's because of the north and south components. Because you're going to have the 0 here, so we're going to leave this part alone. This is going to have to be equal to 0, so then we're going to solve. Yes, Sydney.
So, like, you add the 30 instead of putting it in front of the theta?
Yeah, so when you're adding these two together, this is 0 plus 300 cosine of theta. So you're adding 0 and 300 cosine of theta. Here you're adding 30 and 300 sine of theta. And you can't add the 30 and the 300. Do you guys know why you can't add those yet?
Because there's a theta.
Yeah, do you know why though?
You have to multiply first.
Yeah, order of operations. You would have to multiply before you could add them. Okay, so that's why you don't want to make that like the 330 sine of theta. So when you set your vertical component equal to 0, you're going to solve for theta. So we're going to end up using the inverse sine. And this time when we find theta, it's going to be a little bit different because we are in the west. The wild, wild west. Switching things up a little bit. So once you solve, you should have got negative 5.74 degrees. Now, if you look back at your picture, see how this is where our theta value is? What direction is this? Yes, it's going to be south of west. So when you get the 5.74 degrees, hey, remember before when we were on the east side, it would be north of east or south of east. Now that we're on the west side, it's going to be south of west. It's south if it's negative. It would be north if the value ended up being positive for theta. And then you could also write it west 5.74 degrees south, or you could subtract that value from 90 and say south and then adjust 84.26 degrees to the west. That would be fine. Okay. What other questions do you guys have for me on that one? Okay. Are we all right to move on to 58? Did somebody say no? I don't want to move it if you guys are writing down some work. So speak now. Forever hold your peace. Speak now, but just not forever hold your peace. Oh, it does? I know that's the name of her album. Okay, so for 58, for this one, you're going to have a magnitude of 5, and I believe it said north 45 degrees east. And this was the salmon, so I called it S for salmon. And then you have the current that was flowing east at 3 miles an hour. So to find the velocity of the salmon, you would have got 3.54, 3.54. And then for the current, it would be 30. So if you're finding the true velocity, remember, velocity is a vector. It's just the addition between the object and the force that's on the object. Okay, so our object in this case is the salmon. The force that's pressing against the salmon is going to be the current. So I'm just going to add those together. But remember, salmon has a velocity. So if I said to just find the velocity of the salmon, what would you say? Do you not like the way I say that?
It's just funny how I hear like the velocity of the salmon.
Okay, so this would just be the vector for the fish. No, I don't have to say it. Okay, and then this will be the velocity of just the current, but then the true velocity is both of them together. Okay, and then for 59, okay, for 59, it asks you for just the velocity of the wind. Okay, so if you're just finding the velocity of the wind, you're just going to do the horizontal component and your vertical component. Okay, and then for B, you are just finding the velocity of the jet, and it's heading to the east, so that's why we have the 0 degrees. To find the true velocity, you're going to add those together. And then to find the true speed, you do the magnitude. Okay, so, I mean, these are very similar to things that will be on your quiz, which is on Thursday. Okay, so these are good problems to redo and practice. And then if you need to find the direction, what we're going to do is use the tangent of theta and then our b over a, where you're using the true velocity vector. Okay, so that'll be your direction.
and then you'll get 5.38 degrees. Again, the picture's really going to help because you can see from my result vector, I'm going in the northeast direction. So we could say north of east. We could say east, and then we would adjust 5.38 degrees north. We could start north and then adjust 84.6 degrees to the east. Okay, so any of those would be good for your direction. All right. Are you guys good, or do you need another few seconds? All right, let's go to 67 and 68. Okay, so those were the addition of your forces. And when is no additional force required? Yeah, so when you are already in equilibrium, when you're already in 0, 0. Okay, and then 71, you had to do your vectors, so you had to find your vectors. So remember that for these, you are starting at your terminal side as theta. So like for force 2, you're going to have to use the 150 degrees. So you're going to start here, and if this is 30, you can just do 180 minus 30 to get your 150. For the third force, it's going to be 200 because you're going to do 180 plus 20 to get your 200. And then because our force for part A was negative 7.57, 10.61, the additional force needed would be 7.57, negative 10.61. How did you guys do on 71? Pretty good. Are some of you using like this as a negative vector? Okay. Because you could use the magnitude as negative. Okay, you guys ready for 72? Alright. Okay, so for 72, I think some of you forgot about what we did in 9.1. Okay, so in 9.1, we took vectors from just our coordinate grid. So what you can do is you can look at your picture, and here, we'll do one together here. So, 72. Okay, so if I'm here at my point P, if you look at force 1, all you have to do is find the vertical component and the horizontal component. So the horizontal component is going to be from this point to where force 1 ends up. So see how P is at 2? This one's at 5. So our horizontal component is going to be what? 3. 1, 2, 3. And then this is where P is. So P is at 2. So if F sub 1 is at 1, what's the vertical difference between 1 and 2? Yeah, 1. So then your vector is going to be 3, 1. Okay, so then for force 2, the horizontal distance from 2 to 3 is what? Yeah. So here, I'll draw a picture. Obviously, I don't want to draw it in the book. Okay, so this is my force 2, right? So all I'm doing is I'm finding this unit, which in this case, this is at 2, this one's at 3, so it would be 1. So 1 is my horizontal component. And then I'm going to find the vertical force, so I would be going up 1, 2. Okay, so 1, 2 would be my force 2. Okay, and then you could do that for all of them. So really, you're just naming the vector from the grid based on its coordinates. Okay, so then these would be all of your vectors, so then you could just add them together, and you get 2, negative 4. And then the opposing force you would need for equilibrium is -2, +4. Okay, so these are all the vectors that you can get from the coordinates. Yeah, Kyle?
So is that component form or vector form?
That is both. They'll refer to them as both. If I want it with I and J,
You'll say in
I'll say
terms.
component form with, in terms of I and J.
Okay.
Yes, I know that's,
That's interesting.
I know, yeah. Okay, and then our tension problems, yay. Okay, so, let's see how we did. Jonathan, I put my units here. Okay, so the first thing I did is I set up my pictures. So what we talked about is that the horizontal forces have to be equal. When you're setting up your picture, this is just your horizontal component. So it's the magnitude times the cosine of your angle. Same thing with this, your magnitude times the cosine of your angle. And then for the vertical, it's your magnitude times the sine of that angle. It's the magnitude times the sine of whatever angle that you have. So the first thing I do is set my horizontal forces equal, because if one of them was stronger, then our object would be moving. Then what I'm going to do is solve for t sub 1. You have to solve for t sub 1? No. If you wanted to solve for t sub 2, you could. I just always solve for t sub 1 first. Okay, and then I also know that my up forces have to equal my down forces. Well, my down force is going to be the 100 pounds. That's what's hanging. My up force, or both of my up forces, are going to be my vertical components. So I add my vertical components together, and I set that equal to my down force, which is my weight. So then I'm going to substitute. So I use the exact value here, the cosine of 30 over the cosine of 50. And then I factored out t sub 2. And usually what people, myself included, is we forget that you have to multiply this by the sine of 50 degrees. So the reason why I factor this out is so I can do this all in my calculator at the same time. So in my calculator, I do the cosine of 30 divided by the cosine of 50. I press enter. Then I multiply by the sine of 50. I press enter. Then I add the sine of 30. I press enter. And then I can do 100 divided by that answer. Okay, and that way I'm just going step by step, and I know I'm not going to mess up any parentheses. So then that's going to give me my tension in the second string. And then to find the tension in the first string, you're going to go back to this first equation that you set up and then plug back in your value. Now, I said my answers are exact because I took this value here as it was in the calculator. So the not rounded one, so that whole long decimal that I had, I multiplied by cosine of 30, and then I divided by the sine of 50 to get this. So if you guys are off by a few decimals, that's not a problem. Did any of you do the law of sines method? You can tell me what you got.
Yeah, I got a good answer because I converted it to my equations.
And then convert it back at
No,
that.
I didn't convert back.
Okay, so convert it back.
Okay.
If you convert it back, see if you get something that's close to mine.
You don't need to convert to
I know. Yeah, so, right, if you are doing law of sines, you just don't have to convert it at all, which is nice. But if you did, just convert it back again. So did you do it, law of sines? Yeah. And did you get something close to this? Yeah, exactly. Okay. Okay, good. All right, and then for 74, I think this is the one where didn't the book mislabel it and call both of them T sub 2?
Yes.
Yeah, okay, so you could choose whatever one you want to be T sub 1. I just chose the first one since that's usually That's usually what your T sub 1 is. Okay, so again, the process is the same. And in this one, I didn't draw out the picture separately because I thought by now you guys were getting the pattern pretty good. So you're going to set the horizontal components equal. Notice that the T sub 1 will go with this angle. The T sub 2 will go with the 41.5. I'm still solving for T sub 1 so that I could substitute into my equation that represents the up and the down forces. So my vertical components are going to be equal to the down force, which in this one was 8,278 pounds. And then after I substitute, I factor out my tension, T sub 2, so that I can find this whole number and keep it in my calculator. Okay, so then I do the cosine of 41.5 degrees divided by the cosine of 22.3, then multiply by the sine of 22.3, then add the sine of 41.5, and then I divide this by that answer, so I don't round it yet. And then I do round my answer for the tension, but when I plug it back in to find T sub 1, I leave that whole answer in there. So for T sub 2, I got 18,847.40 pounds. And then when I plug that value into the T sub 1 formula, I get 15,256.94 pounds.